Good evening, all, and very, very warm welcome to our guests, students, colleagues. Just in case you don't know, I'm Gordana Collier. I'm the head of School of Engineering, Computing and Mathematics, and I have a great pleasure to introduce another one of our celebratory lectures. So if you were here last week, we had a lecture trying to remember and understand how it all began in Oxford Brookes in the last century, okay? And we had Denise and James, who are with us again tonight, telling the story of motorsport at Brookes. What they did not tell much about is all the contribution we had from now icons of motorsport who are with us tonight, Adrian Reynard and Pat Symonds, who worked with Denise and James to create a motorsport program to last us for such a long time and be so successful. So, as I said, James and Denise worked on behalf of Oxford Brookes University to create those programs and had great industrial advice from Adrian and Pat. So tonight, a slightly different lecture. Tonight, Denise is going to talk to Pat and Adrian about many things. I shall not spoil the story. I will just welcome Denise, Pat, and Adrian Reynard on the stage, if I may, please. Oh, we're going to start with Denise. Sorry, correction.
Super. I thought it would just be good to just go back to not too far, but just kind of remind you about where I got to at the end of last week's lecture, and as a kind of starting point for this evening's discussion and some of the things that we're going to focus on. Put my slides to go forward. There we go. So I was saying last week at the end of my lecture that one of the things that we were really proud of in terms of setting up this motorsport engineering courses, and as Gordana put it, ecosystem, is that we now have a significant number of people who are employed in Formula One and the rest of the motorsport industry. And this is Renault, Lotus Renault F1 as was, and this was Gordana's slide here, which showed the number of Brookes graduates who are in Formula One. The diagram on the left here, in comparison with some of these other universities, the number of graduates, 295 in comparison to the next one down at 136, which we think is amazing. And I said how many graduates had gone through our programs, and how many that we're one of the top universities for places staying in, students wanting to stay and pursue careers in engineering, which we think is incredibly important. I kind of finished my presentation with saying what's the future, what's going to come on, and obviously we've got things like these amazing new buildings. We've got new activities, Centre of Batteries, Electric Vehicles and Electronics. Are now 2 forming student teams, autonomous and our EV-based team as well. And these are some of the things that this evening we want to kind of focus on a bit in our discussion, that I'm going to try to control and chair with Pat and Adrian, because they had such an amazing input in the beginning of all of this. I have to say that working with Pat and Adrian was a real pleasure, because for me, they're very different in terms of their approach to engineering. Adrian nearly set fire to his car when he was studying here at Brookes.
It wasn't my car, somebody else's
Oh,
car.
that's true. Actually, it was somebody else's car. He's very picky about these things, which was really good. But Pat was always. I loved when Pat interviewed people and he talked to students who were wanting to come into the industry, and he would always make them think about engineering systems in a really fundamental way. Let's take it back down to basics and let's really think about what are the forces here within this system, what's actually really going on. And it was an approach which, I mean, some of you will know that's very much what I like to do with systems, but I admired so much the way that Pat took candidates, whoever it was who came to him. That was always his approach. Let's really try and understand the systems. So without more ado, I'm going to stop with my slides and I'm going to ask Pat and Adrian to come and join me. And for those of you who don't know, this is Pat.
I'm glad we cleared that up.
Fantastic. Right. Hope these are all going to work. So I'm going to start out by, here we are. It's a series all about motorsport, and lots of people think that motorsport is gas guzzling cars. Now, I've heard both of you talk about instances where the application of motorsport has really made a difference. And I wondered if you could say a little bit about that.
Yeah, I mean, my least favourite expression is gas guzzling. I think it's a dreadful expression.
Horrible.
Daily newspapers always use it in relation to Formula One. And of course, what I think they fail to realise is that motorsport is about efficiency. It always has been, and it always will be. And I often illustrate it by saying that when I was a kid, my dad used to take me to watch races. And we drive there in a car that had 2 valves per cylinder and it had push rods and had a carburetor. And we go and look at these wonderful racing engines that were 4 valves per cylinder over cam fuel injected. Well, now you go out into the car park, every single car has that sort of technology on it. And the efficiency that's come from that, both in terms of fuel consumption and in terms of emissions, is absolutely amazing. And it wasn't as if motorsport said, well, what we've got to do is we've got to produce the next road engine. It's just we wanted to be most efficient. And of course, we see that even more so in the current engines, where largely because of exhaust heat recovery, you know, we're hitting 52–53% thermal efficiency.
Mm.
And even in the 2026 engine, where we've taken away the MGUH, we've got a target of 400 kilowatts from that engine, and you work that back, and you're knocking on the door of 50% again. So it's yeah, they're not gas guzzlers. They're very, very
absolutely. Maybe.
Well, I'm not an engine man, but my recent experience is trying to extract as much power out of a 250cc motorcycle as I can. So I've taken an engine which was built and designed by Honda in 1996, but it does have 4 valves per cylinder, and I have put a turbo on it, and I'm trying to extract 115 horsepower out of it. And my maths aren't so good, divided by 1.6, but I think I'm approaching the same as Formula One. But I say I'm not an engine man. Pat is Pat's current. He's been in Formula One working a lot longer than I have. I sort of retired 25 years ago. Just for a bit of history, the only time I've been advanced of Pat is in 1975 when we were both students together at Cranfield. And I definitely knew a lot more about motorsport than he did, because we were in the same class. We did the first year together. It was a 2-year course at the master's degree in vehicle dynamics. And we did the first year, and then I got a job offer. And I went to my professor, Stoller, I think it was, and said, look, I've got this job offer. I really wanted to do my master's degree and get the second year was much more interesting because it was project based. But he said, well, look, what sort of job is it? And I said, well, I'm 25 years old and it's to design a Formula One car as technical director. He said, well, that sounds a pretty good job. And I said, well, I think it is, good offer. He said, well, look, you're only here to get a good job, so I would take it. And considering he was a professor and he really wanted me not to drop out, I thought that was an amazing recommendation. So I'm the original dropout, and that's how I left the motoring motorsport education system. And Pat, of course, went on. He got his master's degree, and then he went on to fantastic, great things. And he can talk about engines much better than I can.
No, I think at the time, Adrian, I said you were absolutely mad. You never get anywhere with it.
Unfortunately, I can't remember that advice.
So following on from that, if you had a young person come to you, they were leaving school or they were coming to the end of or partway through a university course, what would your advice be to them if they wanted to get a career somewhere in motorsport?
Okay, well, motorsport, fortunately, is a very wide spectrum, and they've probably got an interest. So the first thing is you have to be not just have an interest, but you have to have a passion built up. So you need to be focused on what you want to do, whether it's rallying, motorcycling, saloon car racing, Formula One, whatever. So the first ingredient is a passion. It's not easy to get jobs in motorsport, so you need to be determined. And that determined is a capital D, because it's not just the determination, because it needs to be followed up by perseverance, because that's the only thing which is going to drive you through. It's a very competitive world, because Oxford Brookes produces loads of graduates every year, and so do other universities. You've seen Loughborough, Cranfield, etc., etc. So it's now a very competitive market. So perseverance, determination, all these are very, very important. But when I was interviewing, I would try to get into someone's mind, and it was be a case of everyone has a different background, they have different personal experiences, they have a different personality. Some of them we've been talking about. A lot of the people I liked at interview were actually autistic. I didn't know what the word was at the time, I have to say, because it wasn't fashionable to call people autistic. But I think a lot of engineers are autistic, and you say that in a complimentary fashion. So that for me would stand out as someone, hey, this guy is special. And I don't mind if they don't shake my hand properly and look me in the eye, which was the old classic good interview things. But if someone had that special talent, then I would understand, it would relate to me. And I've employed lots of young people out of college. But determination, passion, perseverance, they're all the qualities you need. And you need to have a vision of exactly where you really want to be. They're my opening comments.
Yeah, and I'd echo that. It is difficult, and I'm sure a lot of you, you're doing your course now, you want to get into Formula One. It is a great place to be, but it's not the only branch of motorsport. And in fact, in a way, Formula One has one disadvantage. It tends to be very, very specialised. And people like Adrian and I think our strength lies in the fact that we have been involved in doing so many things. So, for example, when I got into Formula One in 1981, I was the chief race engineer, I was head of aerodynamics, I was head of R&D, I was a designer. I did almost everything except drive the trucks, but I had done that in my Formula Ford days. So, that sort of ability to learn so many things and become a very cross-functional engineer is very, very useful as you go up. And if you go straight into F1, that's quite a difficult thing to do. So don't turn your nose up at jobs in other areas of the sport, because they may well give you a little bit more breadth to what you do. I think also, when you're trying to get a job, you've got this huge funnel of all these students, so different to when we started, because when I first started talking to Denise when I was at Benetton, I was recognizing that we needed graduates, and they were very, very difficult to find graduates. And that's why I felt, you know, we needed motorsport engineering. Of course, now there's a lot of motorsport engineering. There's a lot of students, what from not just with motorsport, but automotive, mechanical engineering, and the other disciplines. So you need to somehow sort of get to the bottom of that funnel, and it's quite difficult. The first thing is your CV. The CV needs to grab attention, because you will not believe how many CVs arrive on the desks of people like myself and Adrian every day. Well, we have our people and culture. They're no longer HR, they're people and culture these days who do sift through. But that's a very dangerous thing, you see, because they are not specialists necessarily. So you need something that makes it stand out. And I have an example of it, actually, that I'm also involved with Cranfield University. And I went to one of their thesis display days one time, 2 years back now. And one of the students I thought had done a really excellent job. At the time I was working for Mauritius. And I started talking to him, asked him what he was going to do, what he wanted to do, and he said he wanted to get into vehicle dynamics. And I said, well, we've got an opening for a graduate, you should apply. And he said, well, I have done, but I've been rejected. So I thought, well, that's strange, you know, this guy's really bright. So then I got back to the factory, I went to see the head of vehicle performance and asked him to dig out this CV, so I wanted to know why he'd been rejected. When I got the CV, yeah, it was boring. You know, it was the same as every other one. But I said to the head of vehicle performance, I think we should invite him in for an interview, which he did, and they employed him on the spot. So that CV is really important. So what do you want in that CV? I totally agree with Adrian. We like awkward people. You know, I like people who will challenge me. I'm not afraid of being challenged. My ideal employee actually is someone who will argue with me all the way until the point where we say, right, this is the direction we're going. Then I want them to be a team player. They'll go along the line at that point. In a sort of CV, I'm looking for people who are competitive. I think that's an important thing. I like to see that people involved in some form of competition. I don't care whether it's squash or whatever. I prefer it if it's a team sport, actually, that gets another tick in the box, because motorsport is very much a team sport. I like to see some practical ability. You know, if people are restoring old cars and things like that, it's a big tick in the box. Formula student is as well, but you need to be able to justify what you're doing in Formula student, because so many people say, yeah, I'm part of a Formula student team. And then when you start talking to them, they're sort of very much on the periphery of it. So, but you do need to show some of that practicality. So I think those are my tips. You know, make yourself stand out, competitive sports, practical ability, a really good CV, and just go for it.
The other aspect that I tend to advise is obviously F1 is quite a magnet and it's best jobs, etc., etc. But the places are very rare. If you get a job in F1, let's suppose your speciality is vehicle dynamics or composites or aerodynamics, whatever, you tend to get into that department as a junior. And guess what? If you're really good, then you become promoted within that pillar. And if you go in as an aerodynamicist and suddenly you become valuable, then guess what? You're going to stay as an aerodynamicist all the way through your life, all your way through your career in that company, because you're too valuable. If you want to be someone with more spectrum in their life, with maybe management, then perhaps you should go into a racing team at a lower level where you can deal with all aspects. You can deal with race engineering, you can deal with the manufacturing side, you can deal with supply chain, you can deal with the drivers and the aerodynamics and the vehicle dynamics, but you get a much broader spectrum. And after a year or so, you will become a very valuable employee for a Formula One team. But with that prospect, you stand more chance of becoming a technical director or someone with a bit more scope than just going up in that pillar. Now, maybe if you love aerodynamics, then stay in that pillar and grow, and because it's challenging and it's changing and there's new techniques all the time. But that's just one piece of advice I would give before you just automatically gravitate to F1 team.
Yeah, and I'd echo that. There's a difference between the sort of high ability and the high potential. The very people who have high ability, they tend to be the sort of subject matter experts at something. They're the people you go to when you really want to know something. They're often very comfortable in their positions. They're quite happy. And yes, they may grow up on a tree on the pillar a little bit, as Adrian said. But to me, it's the high potential people. It's the people who question what's going on. It's the people who are not afraid to move out of their comfort zone. Agile learning, that to me is perhaps the most important thing. I'm of an age where I started in motorsport before we had desktop computers. We didn't know what CFD meant. There was no CFD in those days. Electronics were not on the cars. And I've had to learn all these things. I've had to teach myself. And a little bit facetiously maybe, but when people ask me what my hobby is, I say it's knowledge acquisition, because that's actually what I really, really enjoy. To me, every day is a school day when you're in motorsport. And don't think you leave here and you know it all. You know about 10% of what you need. I've got to about 50%. There's still a lot to go.
That's good. That's good. I think we're living in pretty amazing times at the moment. There's all sorts of stuff that's coming along. You've said how much things have changed in our lives. So we've got batteries, electric vehicles, we've got autonomous vehicles, we've got AI. What do you think, if you were to say, oh, that's a really interesting area, or maybe there's something that you should get involved in, is there anything that really stands out for either of you as, yeah, that's something we should, grasp in terms of knowledge acquisition or whatever?
I think, it's very hard in motorsport to look too far into the future. I've always worked on a 3-year plan, and I roll that every 6 months. So every 6 months I go back and I look at it and I extend it a further 6 months and correct the things that have changed. Hard to look beyond that, largely because of regulation changes and things. Now, interestingly, in the job I've just started with Cadillac, I do have to look a little bit further forward. But really, I think to answer your question, Denise, obviously AI, machine learning, stuff like that is very, very big. It's not on the horizon, it's here, it's now. I've been using machine learning techniques in the design of the aerodynamics of the 2022 car and the 26 car when I was working at Formula One management, using a lot of machine learning techniques. And believe it or not, when I was at Benetton in 1997, I started a neural network program. And we designed our whole data acquisition system on the car, our debriefs, everything like that, so that we could use neural networks to really discover how to get what setup we needed for a good handling car. So in those days, we used to build our own data acquisition systems and things and write all the software. So in a set of data, as well as all the stuff that produces the squiggly lines, so big headers that had the complete car setup, and that had a very objective view from the driver of how the car was handling. And I had to teach people how to be objective on something that's really quite a subject. Unfortunately, I think it was ahead of its time because we just didn't have the computing power to do it. And nor did we have the software. You had to write all the software. And I was actually working with the University of Sheffield on it at that time. But now, you can go and buy it. I've been in Miami this weekend and talking to sponsors and things like that. AI has come up more than anything. There are so many companies out there. Some of them are a little bit dodgy, but there are so many companies out there who want to use artificial intelligence techniques to improve not just racing cars, but your whole business process. So that's definitely
I guess my favorite science as motorsport has been aerodynamics. And I went to the wind tunnel first in 1982. And ever since then, I've thought it's a very powerful tool. And I think it's still probably the most advanced science, most advanced technique that makes vehicles really quick in Formula One. I mean, I don't know whether Pat agrees, but I think McLaren at the moment probably has the best aerodynamic efficiency or use of tires due to good weight control, mass control. And that's so I'm absolutely passionate about aerodynamics. Now, when I started to do it, it was just trial and error. Like you tried something and it was better or worse. And you didn't even know whether the better or worse was quantifiable, because some of the things that looked better were actually worse, because we didn't know about instability, we didn't know about ride height and pitch change and things like that. So that very crude trial and error method has crept on. But guess what? They're still using wind tunnels now. No F1 team would be without a wind tunnel, which is just a trial and error. But of course, they've got fantastic data acquisition. They're probably using AI, not that I know, but they probably are to improve their guesswork. And of course, they've got CFD to validate it, which is a great science in itself. So it is the advancement in AI and of these improving trial and error, because AI is really only advanced trial and error, predicting the future. It's got a very big brain, and it can look at things that probably the human brain can't understand. So I think it's an amazing technique, and I think it's only going to get, at the moment it's used in strategy. I know that in Formula One, but I'm sure aerodynamics is a fantastic application for it.
Yeah, it is used a lot already in aerodynamics. As I say, I used it for the 2022 car. And that was when I really, I think, understood the power of it. And, you know, it's such a broad term, whether you're using pins, physics informed neural network, foundational models. Most people know the LLM side of it, which is not really what we look at. Can be good for a few sort of business cases and things, but it's not really so much the engineering tool as some of the other ones, but it really is good. And, you know, Adrian, it's amazing how the wind tunnels have come on from the time when we used them on your Formula One project. Just the technology in the wind tunnel is absolutely incredible now. And when I take people around one of the factories, many factories I've worked in, right? I show them the wind tunnel model, and I always say this is probably the second most expensive racing car you'll ever see, because they are absolutely incredible. You know, we have continuous motion of them, really accurate data acquisition, many hundreds of pressures that we're measuring over it. We're using PIV to sort of replicate what we're seeing in CFD, so we can see the off-body flows and things like that. Really are incredible. But, you know, a really interesting thing is, you know, how many world championship points you get in the wind tunnel? The answer is 0. And now I'm at Cadillac. We've actually got quite a few graduates, and I took our aero graduates into a room a few weeks ago and started explaining to them just how you use the aerodynamics on the car, because, you know, the number you get in the wind tunnel isn't necessarily what you really want. It's all about understanding the maps, as Adrian was saying, understanding the ride heights, understanding the balance change. I'm a big fan of trajectory tracking, so you understand exactly how the car is going through the corner, what's happening to the aerodynamics as it goes through the corner. You've got positive yaw, you've got negative yaw, you've got steer on it, you've got roll on it. You've got continually changing ride heights, and you have to navigate your way through this multi-dimensional map to understand exactly what the forces are on the car. In many ways, more importantly, the balance of the car. And it's a fact with a Formula One car, but in fact, most people see the racing cars, you never get a good aerodynamic balance, because you've got a lot of work going on with the front wing, which is in ground effect. You've got a lot of work going on with the rear wing, because that's what's really extracting all the air from underneath the car. And that's a fair way away from the ground. So you always get this unstable entry into the corner and then a big corner out of it. And your job's to try and minimise that. You're not going to get away with it from it because that's the basic architecture of the car. But understanding how to apply your aerodynamics is really interesting. And don't get me on about tyres.
I just should jump in it, but Pat mentioned that when we worked together in Formula One, because is it 1990-ish?
Yeah.
I decided to go into Formula One, self-financing, and I hired Pat and Rory Byrne and a team of 20 bright young engineers, designers, and we designed a car. They were all, they had a year off of their Formula One because they were already working in Formula One. But we did some interesting wind tunnel tests. But that was a failure for me. And I talk about failure because it's a very important part of your career, because you can't be afraid of failing in this business. If you're not courageous, it's one of those qualities, persistence. You've got to be a bit courageous. You've got to be a bit ballsy to do things. And this ballsy move almost bankrupted me.
Sorry.
Let me go back, actually. We were at Cranfield together.
I don't think I can.
We were at Cranfield together. So I got this job, Formula One designer for Hawk. Okay. I got employed for 1.5 years. The project didn't go anywhere and I got the sack. Okay. So it was a good gamble because I designed a Formula One car. It was very lucrative for me because it was paying really good money, £4,000 a year, which was good money in those days. Anyway, I got the sack from that company and I went on to found my own company in Bicester and started that going. In the meantime, the company that I hired me, called Hawk Racing Cars, needed someone to replace me. And I recommended Pat. So Pat took the job. That's great. And of course, he was very successful there, designed Formula Fords, or Formula Ford 2000s. Then a job came up, a young guy called Rory Byrne, who you probably heard of. He was the chief designer at Royale, and he left there to go to Tom. And so I knew Alex Hawkridge and I knew Rory, and I said, look, this guy is pretty good. You should employ him from Hawk. So Pat came in and he got the job at Royale, and he designed a fantastic Formula Ford 2000 car, which competed directly with my product, which won the championship, he did, and almost put me out of business.
Okay.
Yeah, thank you, Pat. Yeah. Nevertheless, I still did employ him to do the Formula One car. And that's when we joined ourselves again, and we had some fun doing that. That almost bust me. I sold the wind tunnel model to Ligier for £400,000, which sort of saved me. And I think I donated some of the drawings. I think you probably took some of them on to Benson, wasn't it?
Yeah.
And maybe that helped do the...
The other thing, we developed a lot of the active suspension
We
technology
did,
that
yeah.
year, which went on the Benetton as well.
Yeah.
It was
So
a fabulous.
Don't be
project.
afraid of failing.
Yeah, because, actually, when I say that you've got to keep learning, it's very, very difficult to learn success. You need to be very disciplined to learn success. Very easy to learn from failure. So you got to fail one time.
And we competed in hundreds of races throughout the years. Guess what? I lost most of them. I lost most of the races, and I came back much more motivated. So you don't learn from the successes. You just think, oh, we're winning. Sit back, don't need to release that next development. Makes you fat, dumb, and happy. And I think failure is important.
And I'll give you a really up-to-the-minute example. So at Cadillac, we just produced our first chassis. And it's never intended to race because we had to design it before we even had done the deal with Ferrari. We were using a Ferrari engine for 3 years. But wanted to produce a chassis because the new chassis strength regulations are incredibly difficult to pass. And the 2026 Formula One weight limit is almost impossible to meet. So if you produce a monocoque that passes all its tests, the only thing you've learned is that it's too heavy. So I wanted to produce one, and I wanted it to fail. And I wanted it to fail at sort of 90% of where we get it. If our FEA agreed with that, then we knew we were on the right track. And I'm really pleased that we tested it 2 weeks ago, and that's exactly where we got to. So now we know exactly how to get it to the lightest possible thing we can.
That's good. That's good. Adrian, I wanted to ask you, you drive quite a bit as well, and you've been quite an early adopter of electric vehicles. What do you think is more fun to drive, an electric vehicle or petrol?
Well, I've got more petrol vehicles than I have electric. That's the
Okay.
state. One of them is a 6-cylinder Honda motorbike, which is pretty nice and noisy. The electric vehicles, it's to me, it's a combination. I've got enough space in my house that I've got 12 kVA electric solar panels. So it was a kick for me to actually drive my electric car on solar power. So, and I just about do it all. I think I've had electric cars for 7 or 8 years. I was an early adopter, probably one of the first Teslas in the country. But 99% of my driving is on solar. So that gives me the kick. And I've got 379 miles showing on my car outside because it's a nice warm day. That's nothing to do with the sun, but that's just the battery condition gets better and the range gets better. So 379 miles gets me just about anywhere I want.
That's good. Really good. Great. I've just got one question that I want to ask, and I hope you'll kind of indulge me. We've got these nice new buildings now, and we're moving back to this. We've moved back to this campus. We're doing all sorts of exciting things. Our Formula student team, OBR, it was their 25th anniversary last year. We've got an autonomous team. We're trying to do all sorts of interesting things. And we have produced a lot of motorsport graduates, which I think the industry has really liked. They've really welcomed. If you had any advice to us about what we might do in terms of making good use of these new buildings or anything exciting, you know, and lots of people always say more of the same, and that's in one sense that's fair enough. But is there anything you might say to us that we can chew over and think about what we might do differently?
Well, I think you've got to be in touch with industry, because the whole point that you're here is not just to learn and get a degree, it's to get a job in industry. So the whole point of this is Oxford Brookes must perpetually change and improve and alter what you teach so that it's commensurate with industry needs. Because Formula One and is what I know about, and other motorsport, they change very, very quickly, and the regulations change quickly. And you don't want to be teaching stuff that isn't relevant. So you need a good industrial advisory board that can actually advise you to say, hey, this is not relevant anymore. Don't teach that. Replace that with this. And you know, things like AI, I know it's a separate topic. People get PhDs in AI, but you've got to realize that it's going to become more and more important. So I think that's one of the things is constant. The only constant is change, and you must develop and keep your product relevant.
Yeah, I completely agree with that. Adrian and I both actually sit on the advisory board at Cranfield. And I remember Adrian. They were teaching welding, weren't they?
They were.
Adrian said, "Why on earth are you teaching welding? We don't weld things anymore." And you know, it was a good example of that. So yeah, I think keeping in touch with industry is the most important. I recently came to your battery conference, which I found really interesting. You know, some really good stuff there. But while you're sort of widening your scope like this, you mustn't forget the fundamentals. And you know, to me, automotive engineering, motorsport engineering, whatever you like to call it, is actually just an offshoot of mechanical engineering. You have to get your basic mechanical engineering first. And, you know, a lot of what you get taught in the mechanical engineering are actually the hooks to hang your creativity on. No one can teach you to design, you know, design a car. You can't really teach that. What you have to teach is, you know, the basics of sort of stress analysis, the basics of vehicle dynamics, the basics of engine installations and things like that. So I think, you know, you have to get the basics right, understand them, understand that no matter how clever you are, you cannot break the laws of physics. We've tried many, many times and succeeded. And those laws of physics are exactly the same whether you're working in Maranello or Milton Keynes or wherever. You just can't get away from that. So I think those are the really important things. And I would say, you know, keep up with the latest stuff, so obviously electrification, AI and everything. But I don't think the internal combustion engine's dead either.
No, I don't.
Plenty of interesting things to do there.
The other thing is, on this, Pat said about mechanical engineering, well, that's all that we were available in our day. They didn't have anything motorsport. There was no job. The first job I ever got in Formula One was I was offered a mechanic's job, which I turned down. And when I eventually got into Formula One in 1980, it was I was the chief engineer for March Formula One, and I had one draftsman working with me. So that was, and we had about 4 or 5 guys in the machine shop. So it's very difficult. But you're engineers, you all signed up. I presume you're all on an engineering course. You understand it's engineering. Does anybody here know where the word engineer derives from? No hands at all. It's not surprising, because it's actually, it's a French word. It's a French word. And the French word is ingénieur, surprisingly enough. But ingénieur in French doesn't mean what you think it means. It means an ingenious person. So you all signed up to be ingenious people, not just technician, not just processing stuff, not just thinking about doing things a bit better. You signed up to be ingenious, creative. And that's what you should be. You should be thinking like that, because that's how this country will go forward. That's how you'll go forward. And that's how motorsport will go forward in the UK, by you being ingenious. Think about new ideas. And that's what mechanical engineering is all about. That's the romantic side of it.
I completely agree. You know, I think a lot of people don't realise that engineers are creative people. You need to be creative. And I get very frustrated, particularly with government, where they really don't understand the role of engineers. They talk about scientists. Scientists are very good at pointing out problems, but they never solve them. They always have the engineers to do the proper work.
Great. Now I'm going to open up the floor and see if anybody has got any questions they'd like to either Pat or Adrian or both of them. I think we've got a roving microphone that should, if anybody wants to raise their hand.
Over there.
There we are. Couple of hands now. Couple of hands. There we go.
I can speak it.
Oh, there we are. Prescott's gonna kick off. Go on, Prescott.
Yeah, I talk a lot about uphill, experience in motorsport, build special experience in motorsport, so make it into Formula One, or technical director level. If you have that goal, would you say that there's a way to build that experience from within Formula One after graduating?
Within Formula One after graduating, my view is that Formula One doesn't give general. I mean, you could go into Formula One as management, you know, accountant, you know, building. They do buildings, they do project management. You could go at that level, but assuming all of you will want to go in some sort of technical science, then it's just my view is that you go up in this pillar, you know, we go up. So it's more difficult to emerge from that, from being a senior carbon fiber designer into something in management, race engineering or whatever. So I still think going through a lower level of employer first to get general, a wider spectrum experience is more important. That's what I generally advise people. Obviously, you guys are all different. And, you know, I'm not saying you can't be that. There's lots of great aerodynamicists that have actually gone to greater things, but the science is much more specialized this year. So much more to learn. There's 1,000 people in Formula One teams these days. So they have to specialize.
Yeah, when I was at Williams, I started a program which we called Engineer of the Future. And I used to take one, we had a very, very intense full day interview thing, choose one of our graduates to take on as our engineer of the future. And the difference with between that and the other graduates was the other graduates came into their sort of specialized areas, whereas the engineer of the future had my personal mentoring and was moved around the company to try and get an idea of these, you know, this cross-functional engineering. Now I'm at Cadillac, actually, we're taking on 19 graduates in September. And I think we're probably a bit too early to start our future program, but certainly in the next couple of years, I want to start that at Cadillac as well, because it's the only way of getting people to see all the different aspects of what's now an incredibly complex industry.
If we could use the microphone, please, because we've got an online audience.
We're both very hard of hearing. Stand next to racing.
Hello, I have a quick question regarding knowledge acquisition, actually. For one book you would recommend for technical knowledge in specifically vehicle dynamics or like that sort of more fundamental level Formula One engineering? And what's one book to do with your interpersonal or like your life skills that you would recommend?
Well, vehicle dynamics books, where's James?
There we go.
Great book, got a wonderful forward in there.
Yeah.
Adrian.
Which was the second part of the question?
All the soft skills.
Like a book, a non-engineering, non-technical book that you would recommend that in some way change the way you think or change the way you approach things?
Yeah, well, there's books by Adrian Newey. There's who's the guy who did the Lotus 79? Piece of Right. Piece of Right, very good book there. I mean, that everyone. This is probably you're looking at an earlier generation. You know, if you read Colin Chapman, my hero, he had a totally different set of approaches, and the way he managed his company was totally different. So the constant in motorsport is change. So I don't think you need to model yourself. You should just be yourself, and you can read all the books. There's enough of them. Not everyone's dead either. Some people are still alive. Ross Brawn's got a book. Adrian Newey, as I say. So read them all. You've got to read them all, and you've got to just let it fuel your dreams. And you will say, hey, I really relate to that. That is something I relate to. And that will inspire you. You need to be inspired, you need to be motivated, passionate, determined, you know, and don't give up. Just keep going.
I think the other soft skill that's really important is teamwork. I don't know, I can't recommend a book about it, but it is one of the good things about forming a student, I think, is the teamwork aspect of it.
Thank you.
The front? Or at the back?
Hello. I've got one question about job applications. So just for a bit of context, I've been working for 10 years as a CAD automation engineer in a car manufacturer. I would like to go back to motorsport and maybe work at Formula One. I was wondering if you could have any advice to help me differentiate myself and how should I say, stand out of a crowd of all those wonderful graduate engineers which will be applying soon.
So what's your previous experience?
I'm a CAD automation engineer, so I do CATIA and coding macros, this kind of stuff.
Well, I think we talked about a CV, a resume, make it interesting. It's what we're looking for is the individual, not just the 2 pages. A lot of people recommend 2 pages. I hire people with 20 pages. But you know, you've got this terrible HR filter. I call it a filter these days. You've got to get through. So you have to process it, that it gets through the filter, and then it gets to the people involved. So you have to demonstrate all the good things and, you know, photographs, hobbies, skill sets, and determination. Hate to say it, but you can probably, if you want to bypass, I give it to a few students, if you want to bypass the HR filter, a lot of Formula One teams now, you can actually figure out the internet address and the email address of people. pat.symonds@cadillacf1.com.
Funny, because I keep forgetting.
So if you want it, you know, it's stupid, isn't it? You can actually get to the person you want. So find out the head of the particular area that you want, and then you can actually probably send them a short email saying, look, and you've got to use everything. I mean, when I went for my first job at British Leyland, I just got my HND from here. I never got a degree like that. But I got an HND and I wanted a job at Longbridge, and I was a British Leyland apprentice here in Oxford, and they don't talk to each other. There's no internet in those days. So I had this half-built racing car, which I actually gave a lecture here 53 years ago. That was on this stage or the previous hall. I put it on my trailer, drove to Longbridge, bullshitted my way through the security because I was a British Leyland Longbridge, Oxford person. I found out the person I wanted. I unloaded my car, put it in his car park place, and I waited really early in the morning. And when he came in, he was furious that someone was in his car park, and I was waiting inside his office. It was in the prototype build and development department where Alex Isigonis designed the Mini. That's where I decided I wanted to work. Okay. And he was really unimpressed that he couldn't park his car. But I spoke to him. Maybe you can't do this these days. But I got into his office and he gave me a job. He gave me a job. So that's one way, but it needs you've got to make yourself extraordinary, I think, if you really, really want it. But it still might be possible that way. I was employed for a whole year there, and then I was designing my first racing car at the same time. This was pre-Cranfield. And after a year, I said, right, I think I'm better than everyone in this office. I want a pay rise. And I want a promotion, or I'm going to leave. I left. And I went to Cranfield.
I think the only thing I'd add to that, you know, if you have some experience, if you're a more mature student or later on in your second job, again in that CV, explain what you're doing. Don't just sort of say, you know, 2024 to 2026, I'm doing this, or, you know, I work here. Say what you did. Say what you achieved. It's what you achieved that really matters.
Thank you, thanks a lot.
Obviously, you two have known each other for quite a long time. What's one aspect of each other's careers that you think that you were a bit jealous of, or maybe something to note?
He's rich, I'm not.
Simple answer.
Yeah. But I had to sacrifice a lot for that as well. In the end, I became a businessman. I stopped being a racing car designer. After my Formula 3, I did Formula 3000. By the time we were in IndyCar, I delegated that. I couldn't, we were 195 people then, and I became a businessman. So I started taking business decisions. And in the end, that's where it went wrong. I should have stayed at being a race car designer, probably. But so by taking risks, and it was a risky business, eventually we did multiple years in IndyCar, very successful. But then I took a final risk. We went into the States just before 9/11, and things all went wrong. So I lost a huge amount. I lost the whole company. I lost all the employees, had to go and find other jobs. And you can imagine, I'd employed most of those people. Most of them were young, come from college, graduated. So can you imagine how I felt when I had to speak to them? And I lost, there was 200 people there, and the company went bust. So taking risks is important. The good thing is, this week coming, I'm having a party, and fortunately, I hope most of them come back to my party and forgive me for firing them or getting them fired 30 odd years ago. But no, it wasn't 30, it was 25 years ago. But the risk, it's a risky business. So you take risks and you get rich occasionally. Or not. Or not.
There's one at the back there, or
So, thank you for sharing your valuable experience with students and some of us who are a bit advanced as well. As you've talked about picking yourself up after failure. Can you share a bit of practical ways you did it?
I think determination is what matters, and analysis. Someone was asking about books. A very good book to read. It's a book by Matthew Syed, who writes a lot in the Times, and his first book is called Black Box Thinking. It's all about learning from failure, and it's an excellent book. It's called Black Box Thinking because the aviation industry was the first to really understand the no blame culture, and the fact that, you know, if you analyze things rather than, if you look for causes rather than responsibility, you then move forward. So I think taking that sort of analytical approach, understanding why you failed on something, having the determination that it's never going to happen again.
One of my favorite films was Apollo 13, and it's dramatic, you know, and one of the things that they said in Mission Control was, we've got to fix this. Failure is not an option. But in fact, failure is an option, and it needs to be an option. And I don't think we always need to take risks in designs and development and ideas, and don't be afraid if those ideas don't come to anything. You have to persist. Eventually, you could become a very big failure, of course, if you don't get it right eventually. But I take it that all you are ingenious people, and ingenious people usually come up with the right decisions and the right solution at the end. But getting there, you have to go through the failure mode, and you have to pick yourself up, think about how to do it better and improve yourself, and learn from those experiences. It's all part of winning.
We've got one right at the back there.
Hi, I just had a question because earlier you mentioned the influence that motorsport has had on the automotive industry and just everyday cars. So I was wondering if you've ever found an example of the opposite of the automotive industry having an impact on motorsports, whether it be technically or management wise, and if you would recommend getting experience in the automotive industry.
Why don't you talk about hydrogen? Because that's actually more in automotive than it is in Formula One at the moment. And I know you're an expert on hydrogen.
I'm an expert in not really believing in hydrogen. Now, I can't remember all my numbers. Hydrogen, that's an interesting one, actually, because At a molecular level, of course, it's fantastic. 100 and something megajoules per kilogram against the sort of 43 megajoules per kilogram that we have with the isooctane type fuel. The trouble is, you've got to think at a system level. And the minute you look at a system level with hydrogen, it becomes a bit less attractive. And as I say, I can't really remember my numbers now, but I think to have if you work with a compressed gas hydrogen, the amount you need for a Formula One race, bearing in mind, we start a race with about 4 gigajoules of energy on board. You'd need a tank that's something like 2 meters long and about 30 centimeters diameter or something like that. So unless the driver's going to sit on it, like, one of these fashion cartoons, it gets a bit difficult. You can, of course, go to liquid hydrogen, but now, you're talking of minus 253 or something like that to liquefy it. And one thing I found out, I was talking to Pascal Vasselon, who's now looking after all the hydrogen stuff at Toyota, and the refueling hoses cost €1,000 per meter because of the insulation and vacuum that they have to pull around the keep things cool. I'm not a big fan of hydrogen, actually. But I think it is actually, it is quite interesting to talk about it going the other way, because there's a lot of things that happen in road cars now, particularly with driver assistance systems and things like that, and not things that we want to do in motorsport. So a lot of the development in that area is actually we have no interest in at all. But they do use all the sensor technology that maybe we've developed in motorsport. So it is a bit of a two-way street. And I think it's very interesting in the Formula One context, exactly how the manufacturers interact with Formula One. Now, I left Williams at the end of 2016 and went to work for Formula One management, and my brief was to set up a technical team and think about what was needed for the future. And at that time, I was pretty convinced that the manufacturers who pour so much money into Formula One were actually going to leave Formula One, because everyone was talking about electrification. Even with our hybrid system, we had very high power density batteries rather than high energy density batteries. At that time, people were talking about range anxiety. And I really felt that, maybe they would leave, and what would we have to do about it. But as it turned out, of course, the opposites happened. And, since those days, well, Honda left and came back, Ford had come in, Cadillac had come in, Audi had come in. So it's still a very popular thing. And again, it makes me think that actually the internal combustion engine isn't dead. And I think there's also the realization that actually some of the things I mentioned, batteries, we were developing high power density batteries when people wanted high energy density batteries. Well, they thought they did. Now, of course, they're realizing they actually want high power density as well, because they want rapid charging. And the battery in the 2026 Formula One car, C rating of over 100. And that's a pretty impressive charge rate on the battery. And it's really interesting, because actually that then becomes a mechanical engineering problem. So yes, you'll go for your best power density chemistry to be an LFP. But the real challenge now is designing that battery to keep it at a constant temperature. Like Adrian was saying, he gets more miles with his Tesla in the summer. You need to keep that battery at a good temperature, and you're getting isentropic heating, you're getting ohmic heating. You've really got a mechanical engineering problem on your hands of designing the battery, and things like that really do go back into the automotive industry.
Hi there, thanks so much for the talk. Just a similar kind of follow-up question to that. There's been a lot of talk in the media. I know yourself, you've had some influence with the 2026 rule change. In future years, probably going back or potentially going back to some sort of high revving V10, especially with sustainable fuels being such a thing now that could be used to make it carbon net zero. How hard would it be to keep that kind of innovation there if it did go back towards
those kind of engines that people do want to see in Formula One, like how hard would that be for going back for that technology then to trickle back into the car industry, let's say, with like EU regulations being so strict?
I think I have to say, I was the father of sustainable fuel. You know, it was my project to bring that in Formula One, and I think, you know, at the end of my career, I will look back and say that was one of my big achievements. And it was a difficult one because I'm a mechanical engineer. I have to buy a lot of chemistry books before I could understand what I'm talking about. But I think it is a good example of, you know, how we can push technology irrespective of what we're doing. Now, this thing of going back to the D10s or whatever, it's interesting, but you can't unlearn things. And I'm really disappointed with the FIA. Actually, I'm really disappointed with the FIA. Full stop. I'm really disappointed with the FIA that actually what they've done is they've sort of taken the whenever it was 2005 regulations, and they sort of said, "Oh, this is what we want." Now, you know, that's just dreadful to have an engine with port injection and things like that, and you could actually have a decent combustion system on it. So I don't mind that we go back to a normally aspirated engine, and I think we've got to remember that we are an entertainment business as well, all motorsport is. And if that's what the fans want, great. I have a feeling when we fire them up, they're going to be moaning like hell that they can't talk to each other, but that's another matter. But if we're going to go back to normally aspirated, it needs to be a modern normally aspirated engine. You know, we've got to be hitting sort of 40% thermal efficiency and things like that. And what will happen then with the motor industry? You know, will they still stay with us? And actually, do we want them to stay with us? You know, now we've got the cost out, and Formula One is so successful, we don't actually need the money from the manufacturers. And I rather think you know, a lot of people are still interested in horse racing. They can watch a horse race, but they don't ride a horse there, do they? They'll drive there in a car. I think it's exactly the same. You can have a very energy efficient vehicle to drive you to the race. And if you want to listen to a loud, high revving V10, fine, I don't know what it is.
How exciting would drag racing be with electric engine?
I wanted to have a little bit of follow-up on the hydrogen. I was a little bit more enthusiastic that you were on about hydrogen following my last year's thesis. But we are, I think, entering in an interesting era now for the powertrain, where before we were more on the discovery of aerodynamics, and now with the rise of sustainable fuel, hydrogen, ammonia, or derivative methane from hydrogen, for example. But how do you react from these regulations now? They are more strict. It doesn't allow maybe the teams that could experiment their own strategy of fuel that they can produce, and it could maybe increase the research. Like previously in aerodynamic, there were less regulations allowing some very creative solutions that still today we are using or inspiring from. You said that you were a little bit disappointed from the FIA, but how do you think it could evolve if we let the team a little bit more free about the fuel that they can use?
Well, I think I did. I wrote the fuel regulations for the sustainable fuel, and I was very conscious of the fact that governments around the world, and this all goes back to Dieselgate, things like that, and there's a loss of trust that governments had in the motor industry. What they did was they said, as we want to go carbon neutral, we want electric vehicles. Rather than saying, what we want to do is go carbon neutral. Now, what are you going to do? How are we going to get there? And let clever people figure it out. You've got a load of dumb politicians who said this is the only way to do it. So when I did the fuel regulations, I really didn't want to fall into that mistake, but I did want to demonstrate that this was a very good parallel solution. Because don't get me wrong, I'm not anti-electric vehicle. I drive a hybrid, a plug-in hybrid, and 78. But no, I'm not anti-electric at all. I think it's actually the best solution for the majority of use cases of light vehicles. But what I wanted to do was demonstrate that the sustainable fuel was a viable thing. So what I wanted to do is say, right, we're going to have an EN228 fuel, so a fuel that's very much like a road fuel, slightly higher octane, but that's about the only thing. I wanted it to be an E20, so we pushed forward, a little bit more ethanol in it, accepting that you lost a little bit of energy density, but that didn't matter. But what I really wanted to do was I wanted to say, I don't care how you make this, providing it's sustainable. And that's how I wanted to push the technology. You want to getting the hydrogen is reasonably simple. Everyone's going to do that by electrolysis of water. The only thing you have to do if you're making a Formula One fuel is that you have to use renewable electricity, and it has to be there on site. You can't mix it. But getting the carbon molecules, there's certainly ways of doing it. Whether it's direct air capture, whether it's using municipal waste or whatever. And I very specifically wanted to ensure that we didn't compete with the land use or anything like that. The way I like to express it is you can make the fuel out of potato peelings, but not out of potatoes. That's the sort of philosophy behind it. But I really wanted it to be open so we could develop these different ways of doing it. Because sustainable fuel absolutely has to come into aviation. Whether it will come into road transport is still debatable, but what I felt we could do is we could demonstrate that it was a usable way in road transport, and whatever we developed would be good for SAF as well. And we tend to take a very Eurocentric view because, well, we were in Europe, and that can lead us astray sometimes. So in America, totally different and changing. When Biden brought in the ERA, suddenly sustainability was IRA, Inflation Reduction Act, IRA. Sustainability was really important. Then Trump comes along and his drill, baby, drill, everything's gone back the other way. And so if you, I don't know, lived in Melbourne and you want to go and see your auntie in Perth or something, you're not going to do it in an electric car, are you? So I hope that answers your question.
Yeah, and just going back on that hydrogen thing, I know what Pat's just expressed is all the challenges of incorporating hydrogen in its density and energy into Formula One, for example. Maybe that's exactly something that somebody here will tackle and solve, because there's so many industrial processes that haven't been discovered yet, probably, that maybe this hydrogen, which is the most abundant element on Earth and in the universe, I understand. I mean, why shouldn't we capture it, treat it, manage it, condense it, and use it? It's impossible at the moment. Pat doesn't know how to do it. Nobody knows how to do it. But maybe one of you guys, it's just that the way I look at it, it's just there to be discovered. There will be a new process in the future that is able to draw hydrogen from the Earth, from the atmosphere, from the space, and use it as a fuel, the most common element we've got.
Hi, thank you for your talk. I just wondering if you could think that Formula One would ever go back to a era of, I guess it's still very innovative, especially with sustainable fuels and that kind of thing. But back to the era of active suspension or like powered aero, obviously
the example that comes to mind is DAS that Mercedes had that got banned after like 2 races or something like that. Going back to an era where that doesn't happen, and maybe we could see really good mechanical innovation on those fronts. And I don't know what I'm trying to get at, I guess, but yeah.
Pat's point was it's an entertainment business. Formula One is entertainment business. And not many road car companies are taking too much from F1 at the moment, incorporated in their cars. Active aerodynamics is there. We can do it, but is it good? Is it good?
Well, of course, 2026 cars, a lot of active aerodynamics on it. Road cars have active aerodynamics, some of it quite clever. Things like, you know, radiator slats and things like that, actually quite good. Some of it like, you know, little tails that flip up are a little bit more marketing perhaps and aerodynamic. I think that it's a difficult balance. Again, going back to my time at FOM, which is very interesting, it was very different to going racing. And I guess really, you know, the biggest thing we did there was to introduce the budget cap. And it's something that Ross Vaughan and I were really keen on doing. And there's an argument that once you've got a budget cap, why have any rules, you know, $160 million, do what you like. And it's quite a powerful argument. But again, if I go back to the fact that the sport must be entertaining, it's really, really important that the cars are evenly matched. And our real worry was that if we didn't, and it sounds a little bit arrogant, but we use the phrase, we've got to protect the teams from themselves, which does sound arrogant, but it's true. You know, if the team went off and it spent all its money in its budget cap in a particular direction, and that was a job done much better than any of the other three, suddenly the racing isn't entertaining anymore. And vice versa. If someone had really gone on a concept that didn't work, they couldn't get back, they couldn't fight their way back. So you need an element of regulation. I feel it's gone too far. I feel the FIA over-regulates at the moment. I've got one of the old yellow books from I don't know, 70s or something, and Article 3, it's called coach work, which is a lovely word, isn't it? But it you know, it's a couple of lines and basically a few dimensions for the car. Article 3 now, which is still the aerodynamic thing, is 80 pages or something, and really complex as well, really hard to read. So it's over-regulated, yes, but you can't have no regulation.
Thank you.
I take. Okay, yeah, 2 more questions now, but yeah, one at the back and then yeah.
Hi, thank you for this wonderful evening. It's more of a personal question to both of you. You both have known each other for like quite a while, since many years now. What is the one skill or quality that you would like to learn from each other, if you had the chance?
I wish I had his intelligence.
I wish I had his business ability.
Thank you.
Hi, so my question was, how does a team like Cadillac, or any team for that matter, mitigate the challenges faced from not having a baseline to go off of previous seasons in a industry that is so data driven?
It's difficult. You know, I'll never say that building a Formula One car is easy. It's not easy. But I've done about 40 of them now. And you know the gates. You know what you've got to do. You know the day, roughly the sort of days when you have to release your chassis, aero surfaces, the day you have to have your gearbox done, etc., etc. At Cadillac, we're taking quite a conservative view, so we're actually releasing everything a little bit early because we want to make sure that first test in Barcelona in end of January next year, we're out there and we're running, we've got no spares and everything. But part of the reason is because we've got to build the whole infrastructure around it. And that is actually much more difficult because it's not something that you do every year. If you look inside a Formula One garage and just think about the IT system in there, it is way in advance of anything you'll find in any SME anywhere in the country. You know, we have to have very powerful computing. We have to have worldwide communication with really low latency because we've got people working in North Carolina, we've got people working in Silverstone, and might be racing in Melbourne, and they've all got to be looking at the same thing. If we have any IT failures, we're going to have instant fallback to another system. You know, you don't find that anywhere, and it's building all those sort of things. And even down to the detailed design, I said earlier, 2026, very, very difficult. I think maybe even impossible to get to the weight limit. So now weight becomes a performance differentiator because you know that for every 10 kilograms that you can save, you're going to go 0.3 of a second quicker. You know, it's a fact, it's physics again. Now with all the other teams, they'll be looking at every component on their car. They'll be thinking about the compromises that they've made. You know, we've made it this way because we wanted this stiffness. Now, do we need this stiffness? You know, where's our trade-off? So can we take 5% of the weight of this axle, for example? We don't have that baseline to take 5% off. We have to go back to first principles. And as you say, with very little data, so road load data and things like that, we have to purely do things like it's tough, and I enjoy it.
Thank you. Great.
We have actually got a couple of online questions, if we could just.
Sorry,
ask
yes,
those
I've
as
forgotten
well.
about that. Yeah, go on. Yeah, we've got, yeah.
So one of them is, how do you suggest breaking into other sectors of motorsports? And as a graduate, as in most cases, racing series other than F1 do not look for graduates.
Well, I believe other sectors of other than Formula One is a very successful way for people to get into motorsport because the widespread of experience is much more. The top levels will not be able to give you a wide-ranging experience. So whether it's a motorcycle team, rally team, or a lower formula team, saloon car team, any job I think is relevant to a career in motorsport, and anyone that graduates from Oxford Brookes will be suitable for a job in motorsport, providing they have all the characteristics we've talked about today, which is persistence and don't give up and determination. So I think it's a very good way to go into motorcycles or whatever. And so don't get focused on Formula One. There are lots of opportunities there.
I'm quite surprised to hear that because I thought that other formulas and other motorsports actually did like graduates because graduates are relatively cheap. And it's actually one of the good things that's come to you guys from the budget cap, the cost cap, because there's a much higher proportion of graduates in each team now than there used to be. And again, it's not philanthropic, it's cost saving. But the other thing, is the supply chain. Extract makers of gearboxes had some fabulous schemes for both craft and technician level and graduate level entry. And so cast the net wide because the minute you got your foot in the door, you can walk through it.
Thank you. One more online. So how would you encourage your colleagues to bring forward innovative ideas in a professional environment? Do you have any examples of times where you did that?
Well, I think innovative ideas is what motorsport is all about. So there is development by incremental improvement, which is of course valid. And then there's innovation, which is a higher risk. But if you believe that the engineer is an ingenious person, then it's not at technician level where you might just be incremental. Sometimes you have to take a risk. So being ingenious is a higher risk level, and there's a higher risk of failure. But as I've said before, failure is part of the learning process, and it's part of the success process as well. And it's essential to take risks in motorsport and fail and learn from it.
I think with innovation, you know, again, an example. So I was at Renault mid-2000s, it was a two-mass damper. Two-mass damper wasn't a new invention, it had been around for ages. In fact, when I was fighting the case with the FIA in court, we found examples even on automotive that went back to the 1920s and those. And of course, we've been building for protection and all this sort of stuff. But the way that sort of came about was by collaborative thinking, by a group of people. Firstly, getting that germ of an idea actually from something totally different. We were looking at reducing the vibration on the wind tunnel balance system. And then people talking about it and, you know, brainstorming it. And it's interesting these days, at Cadillac, we work in the office organisation. People can work from home, but for a special reason rather than it being the norm. And the reason for that is because you need to talk to people. You know, you can have an online meeting. If you've got an agenda and you're running through things, I was late because I was on an online meeting. And we were just going through an agenda, and at the end of it, you've got a list of tasks, and that's fine. You can do that online. If you want to be creative, don't do it online. Sit around the table, argue with each other, discuss things, scribble on whiteboards, have mad ideas. That's how you get creative.
And how do you differentiate between being innovative and cheating? Like your mass damper.
It's cheating, isn't it? It's a really good question because you do spend a hell of a long time reading the rules and looking at it. It is part of the job.
Yeah, that's part of the job. Being innovative, looking for rules that don't make me cheat.
Yeah. Great. Okay, I need to bring things to a close, but before I do that, I just want to thank our sponsors for this evening, who are on the names on the pull-up chart there. They've very generously donated funding for, hopefully we'll get, so there's things to eat and drinks after. But just before I do that, this has been I think a really interesting, really fascinating evening. So can we thank Pat and Adrian in the usual way?